Welcome to the Directions Mag GeoInspirations podcast series with Joseph Kursky.
Greetings, folks. Joseph Kursky here with one of my all-time favorite people, Stace Maples from Stanford University. Greetings, Stace.
Hey, good to see you, Joseph. It's fantastic to be on here. And by the way, I am with one of my favorite people in the world, Joseph Kursky.
Oh, shucks. Now, we're going to have a great time because, Stace, you've got a really interesting position there, but I know that many people in reading Directions magazine and in the geospatial world know who you are, but just in case people don't know, could you give a little bit of background on what your position is there and how you sort of journeyed into that position?
Oh, man, that's a long story, actually. So I'll start with what I do here at Stanford. I'm the geospatial manager of the Stanford Geospatial Center, and we are a center in the Earth Sciences Library. We're part of the Stanford University Library System. And our mission is to support the use of geospatial technologies, data, and software in research and teaching at Stanford University, whatever that means at any given time. And so that can mean, teaching on the Esri platform. It can mean embedding directly into projects that our researchers are interested in doing, but perhaps don't have the capacity to handle the spatial data parts of those projects. It can mean many different things, and we have a fantastic staff here that ranges from myself. My background is in archaeology and field data collection. David Medeiros, who I couldn't run the center without. His background is in cartography. He's a fantastic cartographer. He still does beautiful production cartography work. We have assistants. We have a metadata specialist. In fact, we have one of the best metadata specialists in the world in Geo, Kim Durante. We've got some developers in our digital library system who are focused on creating geo infrastructure. So we manage a lot of the projects that have to do with those groups, and we have a really just a sort of a stunning little geo shop here, full of really competent people. It's really great to be here at Stanford. Before I got to Stanford, I actually came here from Yale. I was at Yale for 10 years, doing essentially what I do here at Stanford, but basically without a staff. I was pretty alone at Yale, and I spent 10 years supporting the use of geospatial technologies in research and teaching there, but without quite the capacity that I have to support a much larger patron group here at Stanford. I got into geo originally as an archaeologist. Actually, I should go all the way back to how I got started, because I know there are people who might think of themselves as non-technical folks, might think of themselves as, might be just beginning this journey and might be coming from some field that's completely unrelated. And so I think my story is actually kind of useful. So I began my journey in geo running tattoo and body piercing shops in Dallas, Texas in the 80s and 90s. And what happened was this. I can't remember, it was in the early 90s, Aerosmith came out with a video. In that video, there was a girl getting her belly button pierced. I think it was the lead singer's daughter getting her belly button pierced. And it just went nuts. This is after I already was running tattoo shops, and belly button piercing just exploded. And we couldn't keep the jewelry in stock, and so I needed to learn how to make jewelry for belly button piercings. And so there was a community college in Dallas, El Centro Community College, and they had a jewelry making class. And so I went down and I registered for that jewelry making class. And at the same time, the same semester, they had a humanities class that was being taught at the Dallas Museum of Art. And I thought that sounded cool because I loved the museum. And so I thought, well, I could spend some time at the DMA. So I started back to school. This is after I'd been out of school for years and been running my businesses. And after about 4 or 5 weeks, I learned everything I needed to know about making jewelry, and I dropped that class. But I kept on with the humanities class, and I met an archaeologist from Southern Methodist University there named David Friedel, very famous Maya archaeologist. He wrote a book called Forest of Kings that you should check out if you really love great nonfiction with great narrative. Just a brilliant guy, and we hit it off immediately. And over the course of the next 2 years, I worked with David to get myself into Southern Methodist University. I ended up getting a degree in archaeology. And then finally, what happened to get me into geo was I was working on my senior thesis. And my senior thesis was I had directed a survey of an 8,000-acre ranch out in New Mexico, an archaeological survey. And what I wanted to do was a simple logistic regression on site locations classed by their subsistence strategy, site location against things like distance to water and visibility and soil types and elevation, the kind of common things that we do now. But back then, this was in the mid-90s, and I had no idea how to go about this. And so what I had was a set of GPS coordinates, basic descriptions of sites, and I started trying to transfer USGS topo map data to acetates and USDA soil map data to acetates, and doing it really the old school way. And I spent about 2 months doing that before I realized it just wasn't going to work. And so I got in touch with some folks. I was working with computers at that time. It was probably 96, I think. And I had made my first HTML page by then. I'd made my first web page by then. And so I knew it was probably possible to do mapping with computers. So I started looking for a program, and I found University of North Texas had a fantastic program. God, this guy named Bruce Hunter.
Bruce Hunter, I know him.
Was running a program up there, and I got permission from Bruce to come up and digitize my data. And it took me literally 2 weekends to do it all. And even on a slow computer in 1995, the actual analysis itself took maybe 3 minutes on a computer in 1996. And I was sold. As an archaeologist, I was like, I don't understand why we're not doing this as a matter of the way we do things. Because at that time, everyone was still using paper forms and collecting archaeological data. And that really gave me the bug. Just the ease with which I could analyze that data, create the data, and then analyze it was just, it became a no-brainer for me to use these technologies in archaeology. So over the course of the next 10 years, I spent a lot of time working in archaeology and implementing digital techniques for data collection. I got really into geophysical prospecting methods, things like ground penetrating radar, resistivity, and magnetometry, and did a bunch of that work out in New Mexico. And finally, right about 2001 or 2002, I decided, all right, if I'm going to do this, I've just got to do it. Because archaeology, for the record, it doesn't pay the bills. And so I needed a job, and I was growing a little weary of the whole tattoo world, and it was the things were saturated. So I sold my shop, went back to University of Texas at Dallas, and finished my master's degree in geographic information sciences and remote sensing. I was accepted to their PhD program, but at the same summer that I was accepted to the new UTD PhD program, the job at Yale came open. And on a lark, actually, it was a dare from my wife to apply for the job. She told me if I got the job that she would change her name. We had been married for a while then, but she didn't change her name. She told me she would change her name since we'd have to move and she had to change everything anyway. She would go ahead and change her name. And so the next thing we knew, we were on our way to New Haven, Connecticut, where she had to change her name and everything. But I spent 10 years in one of the best learning environments I could have ever been in for implementing geospatial technologies across, a myriad disciplines. Everything from archaeology to forestry to divinity to architecture. We served the entire campus, including administration, like the development office. And, we were serving everyone. Everyone really got the bug there. And we built a really great program there. About 4 years ago, in fact, 4 years ago this Friday, I started at Stanford, and it's just been fantastic since then. Like I said, we've got this fantastic crew, and the work is just incredible. I work on everything. It's like at Yale. We work on everything from public health applications to digital humanities and everything in between.
This is wonderful. And folks, I wish we had video, because Stace does have some pretty cool tattoos. And
I'm a hand talker too.
That is a fascinating pathway. Another really cool thing is that, how oftentimes we in the geospatial world sort of get reading these reports, and sometimes they're a little bit depressing because when the main person for GIS leaves an organization, oftentimes the program sort of languishes or loses some energy for a while. But I visited Yale about a year ago with Miriam Olivares, and you planted some amazing seeds that she's just, that they're thriving shrubs and bushes now. So it's really neat to see the things that have
Miriam
been
is
sprouting
really,
around.
She was the perfect person to take over there. I think she had been at Texas A&M before that.
Yep.
They had a fantastic.
That's where I met her.
They have a fantastic program, and so she was the perfect person to slide into the Yale program and take over when I came out here to Stanford.
And another good, interesting, I think, encouraging note is that over my travels, I visited about 25 universities last year, for example. I'm meeting more people like you, Stace. Well, not like you, and not exactly like you, because you're really quite unique. You're kind of like a polymath, in the 19th century, that word, with that have deep understanding of a variety of different fields. But anyway, the thing I wanted to mention was that because of these geospatial librarians, we're really seeing a lot of penetration of spatial thinking and analysis in different disciplines. And I'm wondering if you might comment on how we as the community can encourage more of those kinds of positions happening. I mean, we talk to deans and occasionally higher ups than that, but how can we keep this movement going?
So I think, first of all, a couple of comments about GIS support programs in libraries in general. I actually think it's the perfect place to put a support program, a technology support program in general, but GIS specifically. So the first reason is the library is the heart of the university. And librarians touch every department, every center, every unit on campus at some point. And so that's great. It's this opportunity in a person to create the chance for these syntheses of people's research. I would support everyone from forestry to digital humanities to public health, and that cross-pollinated. I became an avenue for cross-pollination, and I think that's incredibly important, and I think that's a role that libraries have really played, traditionally anyway. Another reason I think it's really cool to do this kind of work out of a library is the library is actually discipline agnostic. We don't care if you're from the med school, if you're from the School of Forestry, if you're from history, if you're from divinity, the law school, we don't care. If you can check out a book from our library, you can use our services. And that's just a beautiful way to decide who can use your services. Everybody. I love that ethos, that librarian ethos. So I actually think it's a really great place to put these programs. Now, from the library perspective, I think it's really smart because libraries invest a great deal of money in spatial data. Sometimes they don't know it's spatial data. Sometimes they're investing money in these massive databases that have spatial data components to them. And I think it adds a great deal of value and return on investment to have someone who can help researchers really leverage that data for everything that's in it. We're preaching to the crowd here when we say that, geography is kind of like bacon. You add it to anything and it makes it better, right?
I actually hadn't heard that one before. That's a good one.
But the library is a perfect place to do that from because we see everybody. Everybody comes through the doors of the library. And increasingly at places like Stanford, we're looking at the libraries as these sort of collaborative spaces. We're actually thinking about our spaces and remodeling them and reconfiguring them so that they do encourage these kinds of collaborative workspaces where people can come together. People from different disciplines can trade skills and cross-pollinate each other's research. We're thinking now about spinning up a sort of a digital scholarship lab where we've got people like developers and spatial data scientists and people who are experts in R and visual experts, visualization experts, all co-located in one space so that a researcher can come there and say, I've got this research idea, but I don't know how to operationalize all of this. I don't know how to implement this. What do I do? You have all of those people, the technologists in one place that can do that. You can put together a team really quickly to make that research vision a reality.
That's fascinating. Along with what you're talking about, Stace, I'm wondering if you could comment about the GeoBlacklight technology that you're using to, and other things that you're using to serve spatial data, since a lot of these Directions magazine listeners will be concerned about, hey, where can I get data and what kind of data portal technologies are out there?
Absolutely. So GeoBlacklight is a piece of software that we develop here at Stanford. And the background on GeoBlacklight is this. When you go to a library discovery system online and you search a library's catalog, often, especially in a university setting, you're using a piece of software called Blacklight. And it's just a library search system that sits on top of a very large repository of metadata about the holdings of the library. A couple of years ago, we started experimenting with data discovery platforms that were specifically geared towards geospatial data for libraries. And one of the things that we were unhappy with was the fact that most of the discovery platforms actually weren't geared towards preservation at all. They were geared towards just-in-time kind of delivery of data. They were more geared towards municipalities who need fresh data right then, but aren't concerned with preserving data in perpetuity necessarily. And so what we decided we wanted was a system that sat on top of our library digital preservation system. The system that we put all of our digital assets in, all of our databases, ebooks, spatial data sets, all of these image collections, all of this stuff goes into our digital preservation system. GeoBlacklight brings that back out and makes it searchable. And what's nice about GeoBlacklight is it treats GIS data in ways that makes it very, very easy to discover and evaluate and then access. So one of the things that we realized, the big bottleneck with finding spatial data a couple years ago was, you could Google data all day long and you could find loads of data. And if you finally found a data set that might fit your needs, you would have to download that data set. It might be gigabytes in size because it might actually, your data set that you're interested in might be embedded with dozens of other data sets. Then you've got to pull that down, unzip it, bring it into a desktop GIS and examine it so you can see if it even fits your purpose. So what GeoBlacklight does is breaks all the spatial data out at the layer level. Every layer is exposed to discovery. We have a very simple basic discovery metadata schema. And if you go to, for instance, earthworks.stanford.edu, that's our branded version of GeoBlacklight, you can search for whatever you're interested in finding. So you can search for air. And you'll get all of the data sets that refer to air, which might be air monitoring stations, data sets, might be data sets that have to do with Buenos Aires, things like that. So you get all of that back, and then you can go to a particular layer's landing page. And we've actually built into the landing page of the data sets previews of the spatial data and previews of the attributes. So you can zoom in and out, and it's just like a little web map right there on the landing page. So you can see the data and see if it fits your purpose before you even attempt to download it. From there, GeoBlacklight allows you to either download the original data set, derivatives, or we actually are exposing web services. So we're exposing web feature services and web map services. And what that provides us with the ability to do is to take researchers' data that they've produced in their research, put it into our digital preservation system, and then expose it to discovery and access through Earthworks, and provide them the ability to take their data and operationalize it in interactive websites and things like that, because we're using OGC compliant web feature and web map services to expose. So GeoBlacklight is really about exposing spatial data in a way that makes sense for people that want to actually use spatial data. Make it much quicker and much easier to access that spatial data, and much easier to find the right data. The one other piece of the GeoBlacklight puzzle that I want to mention is that it's a community. It's open source software. You can go to geoblacklight.org and check out the code. You can see our community. You can see example sites. But you can also step into using GeoBlacklight in a stepwise way. So we have different levels. One of the things that GeoBlacklight uses is a GitHub repo called Open GeoMetadata. And Open GeoMetadata is where all of our partner organizations dump their metadata in whatever form they make it. It could be mods, ISO, FGDC, whatever it is. They put it into that repo, and there are tools in that GitHub repo, Python tools, that will convert it, that can convert it to our GeoBlacklight schema. And what that does for us is it provides us a venue to federate search. So when you go to earthworks.stanford.edu, you're not just searching Stanford's holdings, you're searching the holdings of about 25 member institutions so far. And that amounts to almost 80,000 data layers that we've exposed so far. And I think close to 60,000 of those layers are actually in the public domain. So they are freely available to anyone. You don't have to log in to Earthworks to use Earthworks. Some of our license data is behind our firewall, and you have to log in to access that. But all of our public domain data and the public domain data that is exposed by our partner institutions, it's all there for you to discover and take advantage of, for anyone to take advantage of.
Yeah, thanks, Stace. And also the whole idea of you spreading that to other institutions. I know here in Colorado, we've had some challenges in having a decent statewide portal, and the influence that you're having over my colleagues over at the University of Colorado Library, for example. They've got their own instance set up there, and it's making good progress. So thanks for mentoring other people.
Excellent. I love doing that. We're birds of a feather. We really, if I had to, encapsulate what I do most of the time in one word, I would say it's evangelism. Telling people, spreading the word about how powerful these kinds of tools are and what they can do for your research, for your business, for you personally.
Indeed. And since I write that data blog every week, along with a colleague, your site, that Stanford instance, is one of the best. So I can personally attest to the value of it. Also, another thing that you said was really, I thought, quite interesting earlier, and that you started right off with the whole team. You're acknowledging your team, which I loved, because a lot of times people think I've got to be like the lone wolf of GIS in my organization, and we all need each other, and it's really neat that
I am not the most important part of this team. We are the most important part of this team.
I had also forgotten your Dallas roots, and so I was there last fall, 2018, and I visited SMU and talked to Jessie Z over there, and she's great, and went to UTD with May Yuan and others that are there, and also went to Brookhaven with Scott Sayers, and they're doing amazing.
I love Scott. He's so fantastic.
Yep, but I didn't know about El Centro College. So, there's a lot of good things happening in that area.
Dallas is just a fantastic city. I miss it all the time. I grew up there. I didn't leave until I left for the job at Yale. And so I spent most of my life in Dallas. And I just love going back. I go back every year, and I visit the folks from Bishop Dunn High School.
Yep.
I go back and I do their geotech conference. They do for K through 12 teachers every year. I go back, and I've been going for, I think, 3 years now to SMU every year and teaching boot camps for Jessie, because I'm so excited. I mean, since I did that senior thesis and I discovered this thing called GIS, I have been like shaking the archaeologists at SMU saying, you've got to get GIS. And finally, they've got Jessie, and Jessie has given them GIS, and it's just a fantastic program. She's got a beautiful facility. She's got a beautiful teaching classroom, and she's got really fantastic students, and they're doing some really, really first-class work, some really great work. I couldn't be more happy that my alma mater has finally picked up the Geo banner.
Oh, the Geo banner, indeed. When I was there, she contacted some professors over in the School of Business, and I thought, we'll have a half a dozen or so. I went into the classroom with Jessie, and we had about 75 business students, all eager to learn some hands-on. So we did Business Analyst Web. We looked at supply chain management, target marketing, consumer preferences. I mean, it was literally standing room only, people sitting on the floor with their tablets and laptops. It was fantastic. So lots of seeds over in business too.
I'm always really surprised where people are coming from. I always ask when we do workshops and events, where are you coming from? What department? What school are you from? And what are you interested in using this for? And I'm always really impressed with the diversity of applications that we see.
Indeed. It is an exciting time to be in GIS. I'm teaching at the University of Denver, and you probably have encountered these kinds of students at Stanford and the other places you've been where, hey, Joseph, is it too late for me to get into GIS because I'm mid-career? And I'm like, no, it's never too late. This is a good time to be in it because the The problems are they're very complex, and they're very real that we have to encounter, that we have to solve. And then, as you know, as you're making great strides toward, we've got whole mountain loads of data now at our fingertips and wonderful tools. So yeah, it's never too late. One of the things that I wanted to ask you about that maybe not a lot of people know about is that whole way that you got part of the David Rumsey collection over into your library. I mean, that's something that many people have just loved for years. And could you just give them a little hint?
I can tell you a story about that. So the story begins when I was at Yale, and the first time I met David Rumsey. And of course, by that time, I had seen the davidrumsey.com website. And in fact, at Yale, when I got there, they were using the Luna image browser infrastructure for serving their digital images of historic maps and prints and other things from the Beinecke Library. And so Yale was very familiar. And of course, David's a Yalie. He went to Yale University, and he was an art student there. And so David came. I was probably 2 years into my work at Yale, and David came to visit us. We had a new university librarian. He wanted to meet her. He wanted to talk about, this is when he was looking for a place to put his collection. And so we spent an hour or so talking about what he was doing and what we were doing and how those two things kind of overlapped and where this sort of geospatial and the internet was going to take us. And I was just blown away by how forward think. I mean, he has really been at the bleeding edge of this stuff for so long and is still at the bleeding edge of this. And when we were done, I realized we're not digital enough for this collection, because he wasn't just looking for a place for his physical collection. He wanted someone who could handle the whole thing, the digital collection and everything that he's really built out of that physical collection. And so a couple of years later, I heard, oh, well, he's going to put it at Stanford. And that didn't really, surprise me all that much. And later on, talking to David about it, he told me what his thinking was on this. And first of all, of course, he'd have loved to put it at Yale, but he lives in San Francisco. He doesn't want to put his baby 3,000 miles away. That's the first point, and that's an easy one.
Proximity matters. Geography matters.
The second point, and I hadn't even considered this, and it was a great point, and illustrates how what kind of a person he is. He's really interested in sharing, and he realized that the great map collections are all on the East Coast, and the West Coast really didn't have at that time a great reading room, like the Boston Public or the New York Public or Harvard's map collection or the Osher. All of those are on the East Coast, and so the East Coast really has those resources, and he wanted to see something on the West Coast. So that was his second reason. And then, of course, his third reason was Stanford. I mean, if you're concerned with digital and leveraging that and preserving it and evolving it, this is the place. And so he ended up putting the collection here, and it's actually now housed in our main library, the Green Library. It's a beautiful space that David collaborated with us on to design. We opened it 3 years ago. It'll be 3 years Earth Day. We opened on Earth Day about 2.5 years ago, and the space is really, where I mentioned the East Coast map rooms, and they are, you walk into those map rooms and it's really overwhelming. It's an emotional experience because they are so beautiful. But they're also very old looking. Most of them were built in the late 19th century, and so they have that sort of, pipe smoke kind of feel to them. And our center is totally different. It is the center for the 21st century. It takes these collections of historical maps and provides you with the tools in the same space to make them digital and to leverage them in digital ways. And what that allows you to do is things that just weren't possible with historic maps before. So for instance, there's a map called the Urbano Monte. It's actually an atlas, and it's a manuscript atlas. There's only one copy of it. It was made in the late 16th century. And it's a map of the whole world, and it's on a polar projection. And what the atlas is it's the gores of this map, right? And each page is a different little sort of triangular gore. And the intention of the cartographer was to have these cut out and have it mounted on a 9-foot circular board with a pivot at the center so that you could spin it and look at the line, the vertical line of the map that was right in front of you. Well, this never happened because it was impractical, and so this atlas has been preserved in its original pristine condition since it was created by the cartographer. And so David purchased this for the collection, and working with Chet Van Duzer, who is I'm not sure where Chet might be in Rhode Island or Harvard. He works closely with Yale, but Chet Van Duzer worked closely with the Rumsey Center to take this atlas, digitize it, mosaic it, and digitally create the final vision of the map that the cartographer originally intended. And what's great about the Rumsey Center is we have these huge, beautiful screens. We have one screen, we call it the 4x4, and it's 4x4 HD screens arrayed into a single screen. So it's gigantic. It's probably 15 feet high and 20 feet wide. And we can actually put this atlas, reassembled, mosaicked, as the cartographer intended, in its 1-to-1 size on this screen and spin it just like he wanted to have done, without harming the atlas in any way. And these are things that you just can't do without a facility like the Rumsey Center. So we're really jazzed about doing stuff like that. Being able to view atlases and things like that in their full reassembled context, it just changes the way you can use these materials.
Well, that's fantastic. I need to make a pilgrimage there and see it face to face. My colleagues have been there, and they had great things to say, of course. And I've seen your pictures.
We've got to get you out here.
Yeah. Hey, here's another thing. You mentioned David Rumsey and talking with him. I met him, and you talked about the Geotech conference in Dallas. I met him there one year, and you mentioned Aerosmith earlier. He probably thought I was like some sort of rock and roll groupie. I just wanted to kind of just kneel at his feet and just soak in the wisdom. But it was one of those events where I met Bob Ballard there, the discoverer of the Titanic.
Wow, yeah.
I mean, Neil deGrasse Tyson, Jane Goodall. I mean, fantastic people.
Raj and Anita really have something special, and Brad Baker there at Bishop Dunn. They've done something really special at that school.
Well, imagine being a high school student and meeting people like that, and I would love to have some sort of research study to follow up with these students. Like, where did you go after you got out of this school and you met these amazing people and you actually got to talk with them, not just hear some presentation, but anyway.
Well, we're working to get some of those students here at Stanford. I'll tell you that.
Awesome.
Yeah, I've talked to those students, and I do everything I can to encourage them and help them with their applications, because they are some of the smartest students in the world, and they are so far beyond the capacity of most undergrads and grad students with geospatial data science in some cases, because of the quality of that program. They really come at their college search and their university application process with tools that are far more powerful than most people have at their disposal.
Oh, gosh. When people say, oh, middle and high school students can't do this, well, them, but also I went to Saxe High School back in your old stomping grounds, not too far from Richardson, Texas, not too long ago. And the teacher there, he just lets the students fly. So they do GIS animation. So they use Maya animation software.
Yeah.
And when people tell me now, hey, Joseph, GIS it's too complicated. I'm like, you haven't seen Maya animation software. There must be at least 300 tools in the graphical user interface right at the beginning. But those students, they just were tackling it. And many of the students actually get into GIS there because they want to be filmmakers, which is really cool. Yeah, fascinating. So I agree. Yeah.
With geo infrastructure moving to the web and the cloud and everything that's possible just in a browser now, it's really opened it up. This morning, I spent about an hour and a half on the phone with Lauren Sinclair. She's a teacher at the French International School in Florida.
Oh gosh, she was at the ESRI conference last summer. She is a rock star.
Yeah, she is fantastic. And we were just talking through some of the trouble she was having with a few workflows and how she might improve that. and she is using GIS with sixth graders.
Yep.
I mean, she's introducing sixth graders to GIS. She's got sixth graders going out on campus and mapping the campus with Collector for ArcGIS and ArcGIS Online. And it's just really amazing that that the tools have gotten to the point where they're sort of moved out of the way now. The technology has gotten out of the way, and you can actually begin to just teach people spatial thinking and spatial data science in a way that they don't have to be technologists anymore.
Yes, it reminds me, your comments remind me of something that our education director, David DiBiase, wrote that you may recall about a year ago. It was Stop Teaching GIS.
Yeah.
And it was meant to gain attention, but his point was what you're saying. Let's not just teach buffering and overlay. We've got to teach the spatial thinking, critical thinking, and analysis.
Exactly.
So, like you say,
it's about the data now. What we're doing is teaching, exactly like you said, spatial thinking, and spatial data science. Here at the center, we're, like everywhere, we're heavy Esri users, but we are also really diverse users. We look at a problem, at a research problem, and we assemble a solution to that problem using whatever tools are best for that. And that might be some novel combination of Esri technology and open source technology. It might be a fully Esri ecosystem contained solution, or it might be entirely, custom code and open source software. It just really depends on the tools. And what's fantastic is to see everybody sort of converging on standards so that we can do those kinds of things, because the world is much more interesting and much more manageable when everybody can work together, including the platforms that we're using.
Yeah, that kind of reminds me of that. You and I go back a ways here into the 20th century with GIS, and there used to be a GITA.org video called A World in a Box. And the opening segment, I used to show to my intro students, because the opening segment was made in the 1990s and was all about the spotted owl controversy in Northwest Oregon. And the nice thing about it is that it didn't sugarcoat it, saying, hey, after they used maps and GIS, people weren't just all hugging and singing folk songs, But the point is that they realized that the logging community and the spotted owl environmental community both had one thing in common, and that was a healthy forest. They all wanted a healthy forest, and they could gather around these maps and data sets, and then, okay, how can we decide, what kind of decisions can we make based on data? Yeah. And so I just love that story in there, and it kind of reminds me of what you're saying. We're at the point now where, we can actually begin to tackle some of these vexing, pressing issues. You mentioned acetate, also, Stace, and I go back at the USGS to the time when they were transitioning out of manual paper film cartography into really making, NHDs and DEMs and DLGs and all that kind of stuff. I think we had some sort of inkling where this was going to go, but not fully. I mean, we were kind of doing digitally what we used to do with film and paper, making map data. We weren't really I wasn't thinking at that time about this can be used in decision making. No, it was all just to make a digital map instead of making it with the old clunky map. At the time,
data was everything. I mean, it was the data that we needed, right? We didn't have the sort of glut of data we have now. Like now, there's just too much data. I mean, when you can access through a browser 3-meter resolution imagery of the Earth every single day, fresh imagery of the Earth every single day in a browser, the problem is not where to get the data, but what to do with all of that data.
Yep, and we're starting to see a little bit of nudging of, you mentioned data science. In these emerging data science programs at university, I and you and others are always saying, hey, don't forget the G part of data science. So we're trying to nudge that forward, and we'll see where that leads. But that could be a very exciting time, too, because you mentioned the diversity of the community. Many of us still came in from a science like archaeology, you, geography, me, planning, etc. But now we're starting to see, like you mentioned, digital humanities. We're getting these perspectives on where geospatial is going is just going to be wonderful with these.
Oh yeah,
with the increasing diversity of the communities in the field.
And the applications are just like, for instance, digital humanities. I worked on a project with a professor who studies the history of poetry. You might think, well, how is the
Cool.
history of poetry going to leverage geospatial data. And actually what we did was we built a routable network of the streets of London from the 16th century to the end of the 19th century for him, because what he's interested in is seeing how authors conflate geographic space in their work. And what he wants to be able to do is say, when I read something in a piece of prose or a poem that takes a user from one place to another and provides them with a narrative of that journey, I want to see how that author is conflating or exploding, or what he's leaving out of these routes, or if they're even realistic at all. And so we actually built him an application where he can create a starting and ending point and then traverse on a least cost path the city of London, including using ferry crossings. And we've got built into the application the ability to either walk, take a carriage, or go on horseback, which is really kind of funny. But it was an incredibly complex project, as complex as any modern project that we've worked on. And he's just thrilled with the results. But it just shows you that, you can apply these technologies virtually anywhere. I mean, no matter what it is you're interested in, that thing or that event is or happened somewhere. And that somewhere we can leverage with these technologies, and that somewhere matters.
Ah, indeed. I love these words, sir. I wonder if your algorithm there for the 19th century was also watching out for the Artful Dodger and Oliver Twist.
Well, we could put barriers in, so that was
that would be a barrier. Yes, avoiding the pickpockets.
Yeah.
Here's one last thing. You've touched on really everything that I was hoping for and more, but I'm wondering, sort of in closing here, what's your advice to you could either address one or the other. It doesn't have to be both of these, but either, what do you think is the most important thing we should work on as a community? Or what's your advice to a new professional in the field? Could be a new graduate student, could be a mid-career person that's changing into doing a little bit more with geospatial. Yep. But either one of those, do you have any thoughts on those?
I'm going to address both, because I think both of them are incredibly important. The first one, very briefly, as a librarian, I'm incredibly concerned about the ephemeral nature of spatial data. We talked about the Rumsey Center. There are maps over there that are 600, 700, 800 years old. Well, 600 years old. Those maps can still be used. The nature of digital is that, the data that we're producing now, the maps that we're making now, can go away in an instant. All it takes is one keystroke, and that map is gone forever. And I'm incredibly concerned about the lack of concern in general with preservation. I mentioned earlier, municipalities are concerned with things like just-in-time data. They're really looking, 6 months, 1 year, 5 years out. They're not looking back. Universities are interested in looking back. And so one of the things that we're doing lately is beginning to try and build relationships with our Bay Area municipalities to see if we can archive their data, because they don't have the bandwidth, they don't have the storage, they don't have the resources, they don't have the expertise in digital preservation that we do. And frankly, it doesn't make sense for what they have to do with the data. But it makes sense for us, because just like we collect all of these paper maps and atlases and so on to make accessible to researchers in perpetuity, we need to treat digital spatial data the same way. So that's my first, that's the thing I think we need to work on as a community, is placing value on historical data and preserving that historical data. Your second point.
Before you go on to the second point, I'm really attuned to what you're saying, having spent all those years basically from the Cretaceous to the Holocene at the USGS. Yeah. For 17 years I was there, but much of that time I was actually in the publications warehouse where every single map, thematic map, topographic map, book, professional paper, everything was stored. And much of that stuff is, sure, it's in the National Archives or Library of Congress, but some of it's not. Some of it's not ever been digitized. And there's a wealth of stuff going back to like John Wesley Powell and other scientists.
Oh, yeah.
So I'm totally with you.
Yeah, preservation, I think, is our biggest problem, and it's the thing people are thinking the least about, which is one of the things that makes me so excited about libraries really picking up the sort of geospatial data mantle. All right, to your second question about advice for people in general. Everything is somewhere, and that somewhere matters. It doesn't matter if this is a career move for you or not. You should become accustomed to spatial data, spatial thinking. It improves the way you look at the world. It creates an awareness that wasn't there before when you begin to think about the proximity and spatial relationships between people and things and environments. It places you in the world, and I think that's an important. I think one of the dangers of the sort of digital revolution is it sort of creates this existential separation from the real world, and I think geography and maps give that back to us in some way. If through a digital lens, often that's fine. So I think for anyone, playing around with maps and digital maps and web maps is a great idea. Go to davidrumsey.com, check out maps, start making maps. You can make maps on davidrumsey.com now, which is pretty amazing. For people who are interested in geo as a career, stop thinking and talking about GIS. It's all about the data. It's all about the data, and the data is only getting more massive. If you think about it, we're on the verge of this revolution in the automobile industry, where we're going to soon have automobiles produced that have sensors, all over them. And they're going to be producing massive data streams, and all of that data is going to be tied to trajectory, to location. And so we have these massive data streams, and huge numbers of possible data sources, and the applications, we can't even think of them yet. And so what I would say to people now who are interested in thinking about that is the main thing you want to do is develop your spatial thinking skills, and don't worry about the GIS tools. Learn to program, learn statistics, and learn to program. Right now, the best programming languages to learn in the industry are probably Python, JavaScript, and R. But who knows what they'll be in 5 years? They could change. These things, they flux, but programmers, when it comes to big data, have superpowers. And the only way, and you can gain those superpowers just by learning to program. And it has never been easier to learn to program. You can access programming coursework from Stanford for free in these MOOC platforms. Coursera, I believe, has Andrew Ng's machine learning course is free. And so it is just there for everyone to leverage. And I would just say, find what really, really grabs you. For me, it was archaeology. For other people, it might be music. And no matter what it is you are interested in, there's a way to leverage it spatially. And if you can learn to do that, learn to recognize the spatial aspect of things, then you've given yourself a skill that is in high demand. If you can leverage spatial data in things that people aren't thinking about as spatial entities, you've made yourself light years ahead of those people in the hunt for jobs, in the hunt for new innovations, in the hunt for research objectives. It just makes you a better worker, researcher, student, human being.
All right, Stace, thanks for those words of wisdom. Much appreciated. And speaking of preservation, this recording is, just think of it, it's going to go out to the asteroid belt and beyond, as time goes on. So really appreciate your time. I know how busy you are, and I just wish you all the best continued success there at Stanford and all of the lives that you're touching, making our world a better place. Thank you.
Joseph, thank you for thinking of me for this. This has been a lot of fun. I love doing this stuff, and I'm happy to do anything like this for you in particular anytime you like.
Thank you, sir. Thank you for joining us on this GeoInspirations interview with Stace Maples, Geospatial Librarian at Stanford University. And I'm Joseph Kursky, wishing you a great day. Go out and map on.